Good morning and good evening, everyone. Thank you so much for joining today's webinar on clean tech opportunities for U.S. companies and to China. My name is Suzanne Platt, and I'm a Foreign Service Officer at the U.S. Department of Commerce with the U.S. Commercial Service. I'm currently serving on the China desk at our headquarters in Washington, D.C., covering energy and environmental technologies. And now it is my pleasure to introduce Dr. Mark Moese. Dr. Moese has more than 40 years of experience in environmental management and other environmental fields. In his current position as president of Bresea Group, he is responsible for managing company efforts and consulting and training efforts for Chinese government and company personnel. He has led and provided support for the introduction of new technologies, advanced equipment and training to companies and research institutions in China.
Thank you, Susan. Thank you for the introduction. As indicated, I will be talking about opportunities in the Chinese environmental market. And I'll be looking, next slide, I'll be covering 5 topics, including a brief introduction of pricing, then move on to discuss the C&D, wastewater treatment, air pollution, and soil remediation markets in China as they stand today. Next slide. Bresea was founded in 1999 in New Jersey. We have offices in Beijing, Colorado, and Oregon. We have actively worked with U.S. companies to bring technology and help their introduction into the Chinese market. We provide engineering service, strategic management, consulting services, as well as product representation in China. And we've assisted government agencies and private industrial companies and international funding organizations on over 500 total projects. Next slide. So what is the current construction, demolition, debris waste situation in China? Of course, even as in the US, most environmental programs are driven by company policy and guidance. Since the beginning of the urban real estate boom in the 2000s, there has been a soaring requirement for C&D waste disposal and reuse. In 2017, the Chinese government has issued relevant policies and regulations on C&D waste disposal in order to promote the development and recycling of C&D materials. In May of 2000, the government issued guiding opinions on promoting C&D waste reduction that explicitly stipulated that by the end of 2020, a working mechanism for the reduction in construction waste needs to be established in all regions of the country, and that by 2025, all regions, the amount of waste generated per 10,000 square meters, which I believe is about 107,000 square feet, should not be more than 300 tons of waste. Next slide. So what has been happening in the Chinese, in the C&D market in general? Since 2018, there have been approximately 35 cities, including Beijing and Shanghai, that have begun to launch pilot projects, while many of the provinces have developed plans to regulate disposal and reuse of C&D, including Yunnan province that has proposed to increase its C&D waste recycling rate to 35%, as well as programs and policy development in Anhui province and Guizhou province and Hunan province, who has actually planned to build approximately 37 industrial centers for recycling C&D waste by 2020, and a total of 75 industrial centers by 2030, so that they can raise their utilization or reuse of C&D waste to 35% in the large cities in the province, and by 85% in 2020, and by 85% in 2030. So what is the composition of the waste, and what are some of the aspects of the industry? In 2020, the waste generated by the demolition of old buildings accounts for about 46% of the total C&D waste, followed by construction waste from construction sites amounting approximately 29%, and building remodel accounting for about 25%. The debris is made up of majority of steel and concrete and tile and other bricks and debris. Very little wood is found in the C&D debris in China. In fact, to give you an overall general idea how rapid buildings get demolished and rebuilt, the lifespan of a Chinese building is less than 30 years, which is obviously less than the US, where they're generally engineered for approximately 60 years. So the replacement of buildings in general is fast, and a large amount of construction waste and C&D waste is generated every year. In addition, there are obviously natural disasters that occur in China. In 2008, the Sichuan earthquake caused basically about 300 million tons of C&D waste was generated, and that amount of waste basically exceeded the total domestic waste generated by China in 1 year. The other final aspect of the effort is that currently landfilling is still the main means of waste disposal in China. Only about 10% of the waste is currently recycled versus about 70% in other developed countries. So what about the market size, and how is the revenue generated? At present, the revenue in China's C&D waste industry comes mainly from C&D waste transportation and disposal charges. It has grown from approximately 11 billion US in 2015 to expected to be approximately 21.5 billion in 2026. This is caused by the fact that you have from 2006 only about 500 million tons of C&D waste was generated in China. That has grown to 3 billion tons in 2020, and it's expected to grow to about 4 billion tons in 2026. So when one looks at the necessary technology, C&D waste market is expanding and maturing. However, there is a need for advanced crushing and screening technology, as well as technology to reuse the materials to develop high quality building materials from the waste. Not only does China need the main components of the C&D recycling equipment, but also all of the supporting equipment that can be used to support any efforts. In addition, one aspect of the overall solid waste industry in China is that they are looking for additional cost-efficient municipal solid waste recycling and disposal technology. Obviously there is a high demand for foreign investment in treatment technologies in China. And there is a link here on this slide to a report that we've generated for this industry. So now what about the wastewater industry? China is continually growing, has a continually growing population, and is leading to a surge in water consumption, resulting in an increased demand for water treatment and reuse. In 2019, the annual municipal wastewater discharge was about 55 billion cubic meters, and expected to be approximately 63 billion cubic meters in 2021. The main branches of wastewater treatment industry are municipal, industrial, and rural. It's okay, you can move forward. Wastewater treatment market has grown steadily since 2015. It was approximately 52 billion US dollars, and to approximately 92.6 billion US dollars in 2021. and an overall increase of about 180% in general revenue. Next slide. So there's plenty of room to grow, for the market to grow. Although, while the municipal wastewater market is treating approximately 95% of the wastewater generated, there is still a market with the government expecting to invest over, I believe, 113 billion US during the next 5 years. Rural wastewater treatment is lagging. Only about 30% of the wastewater is treated in rural areas of China. Therefore, there's a lot of room for growth in that market. The industrial market, there's a very large market space that can be seen because of the expanded number of and scale of industrial parks that are being built in China and the tightening of industrial wastewater treatment standards. Sludge disposal is always an issue in China as a byproduct of the treatment, and always been a focus of secondary water pollution prevention and land pollution. We go to the next slide. So what are the technology needs in China? For industrial parks, China is moving towards a zero wastewater discharge. They need equipment and know-how on moving towards this direction. Currently in China, they solely use membrane technology and evaporation and crystallization of the materials. Poultry farming is looking for they need cost-effective wastewater treatment technologies to treat wastewater from poultry farms. For the rural wastewater market, they're looking for low maintenance or maintenance-free technology that is obviously cost-effective, and also obviously throughout the wastewater treatment market, technology that can reduce eutrophication of water, lessen secondary pollution, and that it's sufficient and has low sludge production. So what about the air market? As noted in the top corner, the Ministry of Environment last year was quoted in a news press conference as saying that the air pollution control situation is not optimistic and very uneven within the country. To that point, in 2020, there were 337 cities that experienced 345 days of hazardous level pollution, which is less than 107 days less than 2019. But they also experienced 1,152 days of very unhealthy level of pollution, even though that was a decrease in about 514 days from 2019. PM 2.5 and ozone are the largest contributors to unhealthy air quality. And then also China is reducing the amount of pollution emissions over the years. For example, emissions have been reduced by 42% from 39.6 million tons to 27.8 million tons of air pollutants from 2016 to 2019. The air pollution control industry in China, as you can see in the graph, has had its ups and downs and has remained relatively steady over the years. For instance, in 2019, China has produced approximately 34,000 full systems, and that's what's meant by sets here, of air pollution prevention and control devices, which was a slight increase since it was an increase over 2018. In 2020, due to the decline of the overall economy caused by COVID-19, the production of air pollution prevention and control equipment only had a slight increase on a year-on-year increase from 2019. Next slide. So what are the pollution technologies that China is looking for? The air pollution treatment technologies and sensor monitoring networks for criteria pollutants are relatively mature in China. However, they are in need, urgent need, of efficient and advanced technologies for fuel combustion, desulfurization, denitrification, and dust removal. As China proceeds with reducing carbon emissions, they are also in need of emission monitoring equipment so that they can meet their goals, as Susan pointed out. And now for my last topic, soil remediation. As you see from the graph, there is an increase of expenditures from about 300 million in 2016 to 1.3 billion in 2018, and an estimated to be approximately 1.71 billion in 2021. So to give you some scale of the problem, China's land area is approximately 3.7 million square miles. According to the Soil Survey Bulletin, the total area of soil pollution above soil standards in China is 16.1% of the land area. That basically equates to 597,000 square miles, which is larger than the land area of the state of Alaska. If you look at cadmium, where 7% of the contamination is caused by cadmium, that equates to approximately 259,000 square miles, or roughly the size of Texas. If you take nickel, the second highest inorganic contaminant, that 4.8% amounts to approximately 178,000 square miles, which is larger than the state of California. Next slide. China is looking for soil reuse technologies that will, soil remediation technologies that will allow for soil reuse, but also be environmentally protective and not result in secondary pollution. The traditional physical and chemical remediation methods have their obviously own pros and cons, but as the government moves forward to stricter requirements of soil remediation, those technologies need to be integrated more into the remedial solutions. One of the issues in China is that a lot of the contaminated sites, the heavily contaminated sites, have a lot of clay in their soils. And China considers the use of thermal desorption and vapor extraction technologies as not being carbon neutral friendly. So they're looking for other means to remediate contaminated sites that have a high clay content. In addition, over the years, China has used a lot of fertilizers, pesticides that contain inorganic materials. And they're searching for cost-efficient remediation technologies to address farmland issues. And then finally, as Susan had mentioned in her opening remarks, carbon neutral approaches have a bright future, but currently China does not know where the opportunities for carbon neutrality are for their enterprises and industries. And this is primarily because China does not have a clear policy or guidance and solutions for the issue at the present time. And thank you very much for your time.